In this video, we're going to be talking about how do you hear sounds, and this is something I think we all take for granted every day, and I think it's pretty fun to walk through what's really going on in your ears that make you actually be able to transduce sound pressure waves, air pressure waves, and recognize that as a sound and identify it. So we're going to start off by looking at the outer ear. So this is a cross section of an ear. So if we just sliced your face off, this is what we would be seeing. And so the most lateral thing we're looking at here is this outer ear. And so the outer ear has got a bunch of cartilage. It's also got some fat, and they form these shapes, and we call this structure the pinna. And so basically the pinna is having the function of directing sound pressure waves that come from any angle towards this guy right here. So this guy right here is called the external auditory meatus. And I always think meat when I see that, but whatever. So basically, sound's going to come, it's going to bounce off the walls of the pinna, and basically you're going to get all these sound pressure waves that are going to want to start going into this ear canal, this external auditory meatus. Meatus literally means hole in Latin. And so basically what's going to happen is that you're going to get all these sound waves that basically, I should use a different color, are going to start coming in here. And just like that, they're going to make their way down and eventually strike this thing right there. And so that guy is called your tympanic membrane. And so the tympanic membrane is important because it is the barrier between your outer ear and your inner ear. So the inner ear is where we are going to basically take these sound waves that have just struck our tympanic membrane and then move them onto our inner ear. So it's an interface between these two things. And so the technical names of these guys are as follows, and the way I remember this is MIS. So basically the first bone directly connected to that tympanic membrane is called the malleus, just like that. Then we've got another bone right here. I'll try to make this clear. This guy is called the incus. Sorry. And then finally, we've got this little bone right here, which is called the stapes, not staples. And so why are there three bones here? That's something I ask myself when I'm learning this stuff. And one of the reasons is that by having three bones, it allows for your body to have these muscles that will basically pull on these bones to help reduce how loud sound is when there's sounds that you don't want to be hearing. So an example of this and one of these muscles that we care about is this thing called the tensor tympani. So tensor tympani or tympani. So this guy is a muscle that is going to flex. It's going to contract when you're chewing food or when you are shouting at somebody. And the reason for that is because when you are generating sound waves inside of you, your brain doesn't need to hear those. Your brain is trying to hear stuff outside because that's more important than what is going on inside. So like if you're chewing gum, your brain is trying to tune some of that out, so it's going to engage this tensor tympani muscle. Another one of these muscles is the stapedius muscle, and the stapedius muscle connects onto that stapes bone right here. So even though there's all these little bones here, the three smallest bones in the body, it is nice to have divided them up so that there is this control over whether or not these bones are going to be fully engaged. And the reason why we want to do this is because this is a nice segue, ties into the purpose of our inner ear. And so our inner ear is where we're actually going to do the magic of turning these sound waves and vibrations that have just been conducted through those three bones of our middle ear into signals that our nerve is going to actually detect. And so the star of the show here, for our intents and purposes, is going to be this guy right here, our cochlea. So the cochlea has the job of basically recognizing all of this sound. And so the inner ear starts at this structure right here, and I'm going to try to use some good colors. What I want you to note is that the stapes bone is hammering against this thing on your cochlea called the oval window. And the oval window is a membrane. It is an interface to the insides of this inner ear. And so what happens is that when your stapes muscle is knocking on that oval window, it's going to cause pressure in the fluid inside of this cochlea to vibrate. And specifically, what's going to happen is that we're going to cause a very special type of fluid called perilymph to have these pressure waves inside of them. We'll get to that bit in a second. But another feature or structure I want you to note here is that in addition to the oval window, the cochlea also has this thing called the round window. And so the purpose of this round window is basically relieve pressure waves, because if you had a balloon and you only had like one entrance to this balloon, if you were to press on that and create a pressure wave inside that balloon, that pressure wave is just going to resonate inside that balloon and never leave. And so you need some way of relieving that pressure once it's entered your balloon to get out. And so that's the purpose of this round window, is basically provide that relief. And so that is the key thing to take away from this. Another thing to note here is that you're going to see how there are two nerves coming off of this guy right here. And so one of these nerves is going to be called your vestibular nerve. So I'm going to try to use colors that are unique to this region. So this guy right there is called your vestibular nerve. And this guy right here is going to be called your cochlear nerve. And hopefully these names make sense. So the cochlear nerve is coming off that cochlea, and the vestibular nerve is coming off the vestibule. And the vestibule is responsible for helping you determine where you are in three-dimensional space. So if you're rotating your head, if you're looking up or looking down, if you are tilting your head sideways, the vestibular nerve is that thing that's sending these signals to your brain to tell you where your head is. And so together, these two guys actually come together. So this is a little fun fact. So these two nerves come together to form the vestibulocochlear nerve. And so this guy is actually one of your cranial nerves, specifically cranial nerve 8. So this is a nerve that literally comes directly off the brain itself. So it's a pretty interesting nerve that you will study a lot in anatomy. And so now that we've done that, we're going to take a little bit of a deeper dive. We're going to zoom into this cochlea right here. And I'll try to use some colors that are good. So we're going to scroll down. And so this right here is a stock image from Adobe. I'm poor. But basically what we're looking at, again, is that cochlea. And so specifically, just to reorient ourselves, we've got our stapes bone right here. This was in that mid-ear, and that's pounding on this structure right here called our oval window. And then we've got our little round window here, our relief window right there. And this overall structure is called our cochlea. And so what is happening inside this cochlea when we're doing this stuff? So the key thing to note here is that as the stapes is vibrating back and forth, so this guy's going like that, many times per second. So like A440, 440 times per second is what musicians call the note A. So a bunch of those vibrations, 440 times, is going to create a 440 hertz wave of pressure fluid that the stapes is knocking on this oval window with. And as it does that, it's going to create fluid pressure waves. And so from air, we're going to turn into this other fluid that is inside here called perilymph. And specifically, this blue structure that we're looking at, that is going to go down here and it's going to swirl around. This guy is what is referred to as the scala vestibuli. So, perilymph, this is the fluid, that's the ear juice, so to speak, is this thing that's going back and forth, and it's traveling down the scala vestibuli. And so the scala vestibuli, I'll abbreviate this SV to save my hand, is this thing that's basically going to keep running down here, and this is a cross section of that area. So if we were to take this and then blow it up, this is what we're seeing. So you've got your scala vestibuli, and then you've got your perilymph fluid, which is the actual inside fluid of this thing, is going to be running against that. And an important membrane inside of this is this guy right here, and this guy is what is referred to as your vestibular membrane. And so the reason why we care about the vestibular membrane is because as you move down your cochlea, I want you to see how the diameter of this pipe is decreasing. Basically what's going to happen is that as these diameters get smaller and smaller, eventually there's going to be a point at which your vestibular membrane, your VM, is going to resonate with the particular sound, the pressure wave that was just created by the stapes bone. And so when the vestibular membrane resonates with the sound wave, something special happens. And so when this happens, the basilar membrane, which is going to be this guy right here, is also going to start vibrating. And it's going to be vibrating at a slightly different pitch than the vestibular membrane is at. And so the reason why this is important to us and why we care about it is because we've got a very special organ here. So this organ, I'll use a good color, is something that's referred to as the organ of Corti. And this guy has some special cells in them that have this thing called hairs. And so hairs detect different movement between the vestibular membrane and the basilar membrane. And so when you get these two membranes that are now resonating at their own special frequencies, so that guy's doing that frequency, this guy's doing its own frequency, the organ of Corti is going to recognize that, specifically the hairs on it are going to recognize this, and that is going to be what actually transduces a signal to go eventually to your cochlear nerve. So this guy right here is a nerve leading to your cochlear nerve. And hopefully, as the name implies, so cochlea, keep thinking sound transduction, how your body's interpreting sounds. This is how we ultimately are able to perceive these sounds, because the organ of Corti is seeing that there's this difference in frequency between the vestibular membrane and that basilar membrane. And so by seeing this, that is the important thing that is allowing your brain to actually register any of the things that I'm saying right now, which is pretty cool. And so the important thing to note here is that once these sound waves have basically propagated through the scala vestibuli and that vestibular membrane, and then they've also traveled through that basilar membrane. They travel all the way back out to here, and right here is called that round window, and this is the guy that relieves that pressure wave. So after you've heard that sound, that A440 hertz sound, your ear and brain no longer need to hear it, and so you can forget it. And so that is the key thing to note here about what is going on in your ear to actually transduce sound. So this is how we hear sounds. I hope that this is interesting stuff. Let me know if you have any questions. Thank you all for watching. I'll talk to you guys next time.